Hello all, this is Viresh here. Uh, I'm here to present on my project assignment. I just underwent the course for machine learning foundations for product managers from Coursera. I'm part of Schneider Electric. Before going into further details, I just thought of, talking about four different criteria as what were highlighted by the Duke University course, what kind of approach we select for modeling, how do we build the models, how do we evaluate, and how do we interpret it. Now, instead of talking, in PPT mode, I would like to directly jump in the practical stuff. So let me take you to the another screen. Um, Now, I can really talk about approach building, evaluation, and interpretation. Maybe before that, I would just like to show the step-by-step approach what I followed. So I simply imported the file which we received from the course, which is called SACPP data CSV file. Post updating or uploading that file, I found that there are almost 19,568 records. There are five different columns, or I can also call those as five different features available, which are nothing but AT, P, AP, RH, and PE. So P is basically the resultant what we are expecting or the answer what we are expecting from the machine learning, right? So now, when I run the correlation, now we are basically in the model building, or I would say even in the feature understanding mode. So when I run the correlation, it shows that, the PE feature has negative correlation with the AT and B. Also on the other side, the RH feature has the lowest correlation with the target PE, right? So this is what I understand. Now what I am doing is, since P is basically the answer or target what we are expecting, I'm calling P as Y variable, and trying to run the different codes. Now out of these five features I have removed PE and just trying to run the correlation between the remaining four fields like ATB, AP, and RH. Uh, Also, on top of that, when we are talking about data understanding, I should really understand that out of these four features, which is the most important feature and least important feature. So if I run that query, it shows that, uh, AT is the most important feature. This is basically in a descending order, whereas RH is the least important feature here. Now, when we go to model building, there is always a challenge that what kind of algorithms we are selecting. So what I have done is I tried to select two different algorithms. One is linear regression and another is random forest, right? Now, when I go with random forest, I also wanted to have a better performance or better accuracy understanding. So what I have done is, try to use a different depth parameter for random forest. So here you can see once I have run as 2, another time I have run as depth as 3, and then finally I have run depth as 5. Okay. Now, post building this model, let's try to understand what is happening. Uh, uh, um, so I also, splitted this data in 70-30 ratio. Some can really use it as 80-20 as well, but I was really, thinking that, 70-30 might provide us the better results. So here you can see train versus test is 70-30. Now when we run the results, um, mm, 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 let's see the R square first, when we go by train versus test data. So on test, the maximum R square we are getting from the random forest with the depth as 5, whereas the second best is 0.9271, which is outcome of linear regression. So here the best algorithm would be random forest with depth of 5. Now, when we talk about MSc data on the test, so the lowest score, which is 17.95, is basically resultant of again random forest with maximum depth as 5, and the second best is 21.24, which is again a result of linear regression. Now, if you talk about the final product, which is RMSE, let's not talk about trend data, we talk about test data here. So what we are getting is the lowest score, lowest RMSE is again a result of random forest with maximum depth of 5, whereas the second best is 4.60 with linear regression. Now, it becomes a bit difficult, to understand which model is giving which better value. So I try to summarize everything in this table. You know, I'm talking about now I have not considered linear regression here because, it is like kind of second best. But when I talk about random forest model, which is the most suitable model here for the data set what we have, I try to show, three different models with three different depths, 2, 3, 5. And what I found that the maximum depth of 5 is offering us the best numbers. So generally we say R square should be maximum, which is maximum here 0.938. The MAC should be lowest 17.95, which is again a resultant of depth 5. And RMSC, which is again a lowest 4.23, which is again a resultant of random forest depth 5. So I believe, I try to cover all the four criterias, which is like modeling approach. Then we talked about model building, how do we select the algorithm, whether linear versus random? And again, if we select random, do we really play with different depths? We also talked about, having data split of 70-30. We talked about model evaluation. We talked about three different features or, the resultants R square, MSC, and RMSC. And finally, when we try to interpret, we found that, as the depth of, random forest model goes up, it actually offers us more accurate results and better performance. I think that's all from my end. Thank you. Thanks for watching this. Have a nice day.